Hello, my geeslings. It is Mother Goose, Robinson Earhart, here with the introduction to Robinson's podcast number 63. And this episode is with Thomas Ryckman, who's professor of philosophy at Stanford University, and Mark Wilson, who's distinguished professor of philosophy at the University of Pittsburgh. So Tom works on the philosophy of physics. Mark works on the philosophy of physics, philosophy of math, and their intersection with philosophy of language and metaphysics. And this episode was pretty serendipitous. Lucky for me, ever since I got here, I've been trying to get Tom to do an episode with me on Einstein or Niels Bohr, who he's working on now. But when I invited Mark to do an episode with me, he immediately suggested that I orchestrate a joint session with Tom. So that worked out perfectly. And Mark already had a topic in mind. He wanted to discuss the current state of analytic and academic philosophy. So for that reason, this episode, I think, is much more applicable to or of interest to people who are up to date on contemporary philosophy, perhaps graduate students, professors. So in addressing the state of analytic philosophy, we talk about ideas from the 20th century that might have been forgotten. We talk about some problems that Mark and Tom have identified. So there are some spicy comments on Wittgenstein and over-reliance on logic in 20th century philosophy and now into the 21st century. Problems with possible worlds. And we finish with some final thoughts on philosophical training. So without any further ado, I hope you enjoy this podcast as much as I enjoyed talking with Tom and Mark. So when I asked Mark if he wanted to have an interview with me, he immediately asked if I could arrange a joint session with you, Tom. And then when I looked at some of the materials to prepare for this, I immediately saw that you, Tom, wrote of Mark that he's the moral compass of analytic philosophy.
Right.
So it's pretty clear right off the bat that you two have a great deal of respect for one another. And
except I don't know which way his compass points.
Mm-hmm. But so I was just immediately curious about how you two met and how you developed this sort of rapport. What sort of things you guys were talking about at the time?
Well, go ahead, Mark.
Well, I met him when I was teaching at what I call Chicago Circle because of its the way Mayor Daley set up that university. But it's now Illinois at Chicago. And Tom had come to Northwestern, I think. Mm-hmm. And so maybe Michael Friedman introduced us. I can't remember. But
I think it was probably Michael, who was then at Chicago Circle. And I would run into Mark on campus and then at Powell's bookstore, where he would be buying, a textbook on partial differential equations or something like that. And this happened more than once, I think. And then we lost touch for a number of years. And suddenly he started writing these wonderful books, Wandering Significance, Physics Avoidance, Imitation of Rigor, which I think is a gem. There are many gems, but the Imitation of Rigor is manageable in less than 200 pages, which for Mark is quite an achievement. And it is an alternative history of analytical philosophy, which is really summarizing a lot of what Mark has been about in those big tomes. And it really is telling, I think, us that one, to be a philosopher has to be a philosopher of language. And no matter what your specialty is, you have to have some sort of understanding of reference and semantics. And no, I'm not going to talk about reference for 3 hours. But Mark has made it very, very clear that linguistic usage is key to how we form concepts and how our concepts are guided And I think with these beautiful examples from continuum mechanics, which nobody that I know except Clifford Truesdell, has investigated so thoroughly, and not as a philosopher with Truesdell, but that there's just these architectures, if you like, these different levels of modality of meaning. And what it does, I think, for the analytic philosopher is tell us that we have to get away from this kind of closed linguistic system picture of a given discipline, whether it's physics or the philosophy of mind, whatever it is. It's got to be some closed system where there's no room for semantic expansion and contraction. And through his examples, Mark gives us many illustrations of how this actually works in applied mathematics. And I think that's a salutary lesson in philosophy of language and semantics for analytic philosophy, one that sadly few analytic philosophers have heeded, but I would like to see it made more general. That's why I like Imitation of Rigor, because I actually think that is the most approachable of all Mark's books.
Did you say that that's the 200-page one?
Yes.
Yeah, because I was looking at Wandering Significance, and it was 700 pages, which I just can't imagine putting together as a philosophy text. But
well, I am not. I have certain colleagues that have grand views of the universe. The only reason that one is so long is that as I tried to work out some of the ideas and would give them in talks, I got such horrible reactions that I thought I was ruining my career. So I decided to get it out of my system. So that's...
And it took 700 pages.
Well, also there's a thing, I don't know if Tom ever knew Jeff Joseph, but I do believe that sort of a philosophical joke is worth, well, this is contradictory, should be worth about 300 pages. That didn't keep me from writing 700, but I was trying to bring the humor out, the real life humor in the way language develops. And so if I had a curious example, I'd throw it in. And doing a lot of that, it gets long if you're sort of a collector of curios. So that's what makes that book a little bit different. And
so back in Chicago Circle, were you two mainly talking about philosophy of physics or how it intersected with philosophy of language? I mean, it was probably over a period of years, so I'm sure you touched on many things.
Well, back in the day, when you were first there, you gave me a copy of Weil's book on group theory, but I thought you were more oriented towards Schlick, that I didn't know that much about, and then the heavy duty Weil stuff came later, I think.
Yeah.
And that's a tremendous accomplishment, and I still find him very difficult, but what I've read of him. So even Imitation of Rigor is more about the background of notions of axiomatization and so forth, which are in the background of Schlick and implicit definability and all that sort of stuff.
Sure.
But I think where Tom and I would agree, and this is what we talked about when Tom came out to comment on one of my books, is that analytic philosophy has really forgotten its roots and the problems and considerations that prompted it. We just had a talk here the other day. I better not name who, but it's of the current crop of metaphysicians, and they have this notion about grounding. And he had some view that would ruin the capacity to take a corpus, a theoretical corpus, and by finding different primitives, find deeper relationships, to have a new perspective on geometry by having a different set of primitives, all of which were in the background and motivational for Frege and Dedekind, all these sorts of people. And this fellow just had ideas about the grounding of properties and their proper definition that was completely contrary to the origins, insofar as I can see it, of a lot of analytic philosophy. This awareness that science tries to get deeper insights by taking an established body of doctrine and finding unexpected ways to carve it up and look at it and what the structure is, you know.
Yeah. Let me ask you two more about that. I mean, just to give us some more context. I mean, so the questions are, what was analytic philosophy born out of, and what is analytic philosophy as it should be that distinguishes it from some of the other traditions like continental philosophy or Eastern philosophy, maybe?
Well, let me just give you a 25 word or less précis of Imitation of Rigor, where Mach basically starts with problems that in Hertz's mechanics, and Hertz was thinking about notions like force and cause, and so he gave the idea of this axiomatic construction, which is how you could give meaning to these terms. And you got the idea of a scientific theory, of a physical theory, as being this kind of whole connected organism. And this passed on, I'm being very brief here about Hertz, but this passes on to people like Carnap, who try to talk about how and to get rid of metaphysics, we have to have linguistic systems and these closed semantic vocabularies for each possible linguistic system. Immediately, we have the principle of tolerance. We can choose different languages in which we can discourse, but the languages are essentially semantically bounded. And we have the idea that if we go outside of that, we're going to be engaged in some sort of metaphysical enterprise, which is hazardous to philosophical health. And this gets then passed on through people like Carnap. I've left out Duhem, who was very much important to people like Quine. And ironically, this kind of Carnapian conception of anti-metaphysics has produced analytical metaphysics, you know, this idea of these semantic relations of properties and fixed vocabularies and the attribution of properties in these fixed vocabularies. And it's led to this picture now of you can do, you know, investigations of reality using just logic and cleverness in analytical metaphysics. And it's an ironical tale because, as Mach says, analytic philosophy has forgotten its roots. It's forgotten the kind of problems that Hertz was dealing with notions like force and cause, and how these have these polyvalent significances in different applications and different usages. And this is not in the picture that we have in philosophy of language and analytic philosophy. It's very much of a Marx's view in my mind is very much a kind of late Wittgensteinian view of usage and how it has to be flexible, and we have to understand meaning in terms of context.
What you're saying reminds me very much of my conversation I had with Tim Maudlin on the show, when he was saying that if you're going to be engaged with the metaphysics about the actual world, physics needs to be first and foremost in your mind and informing your metaphysics.
Well, I think, yeah, but by physics, I think Tim means something different than Mark does. So, I mean, Mark is really looking at where the rubber meets the road, where you apply mathematics to specific systems and subsystems in order to get tractable answers to what observation is all about. So I think that is the real difference there.
So Hertz had, there's a famous quote from Hertz that I work upon, which says that his motive, he didn't, so people regularly, the positivists, thought that Hertz was complaining about force being a metaphysical notion. And that's reading this sort of Carnap reading back into Hertz. But Hertz says, I'm not complaining about force as a notion. It's just that as we've learned to deal with the physical world, he says, we've accumulated more requirements on the notion of force than are self-consistent. So he thought of axiomatization as weeding those out until you got something that was self-consistent. And but he didn't believe he was doing analysis of meaning in anything like well, back to the original thing about what is analytic philosophy supposed to be. Well, often in Russell you get the idea, well, we have concepts that come to us and they're kind of confused. We got to sort through them and find a good concept for the notion of derivative. And once you get it, then that's forever. Okay. And Hertz is saying, I don't believe in an analysis like that. So he's more like a pragmatist. We build up all these relations and then we get too many of them. And that is something that Hilbert often says. And Hilbert seems to have been inspired to look at axiom systems for geometry, inspired by Hertz's book. And then he actually put what Hertz's project is number 6 on these mathematical problems, thinking that somebody could do better about continuum mechanics, among other things. And so the other thing I was going to say, just fitting in here, that quotation I'm talking about, for most of the philosophical investigation's existence, was the motto before Augustine came into it. And he always credited Hertz as being a chief inspiration. Now, exactly how, I don't know. My brother used to work a lot on a Wittgenstein interpretation, and I've occasionally done it. But, you'll read a couple of pages and think that you've caught on to something, and you go another half page. And so whether I'm very reluctant to claim, I've certainly read a lot of Wittgenstein, and I actually found some stuff in Weissman recently that I could actually use as a coat rack to put some of my ideas on. That's what I sent you to look at. But I'm very reluctant to cite Wittgenstein as an authority for what I'm doing, or that there's so many people say, well, of course Wittgenstein says X, right? Mm-hmm. And I don't know if you ever teach Wittgenstein, Tom, but the worst thing about Wittgenstein is that people think that they are able to channel the great man, and so they start talking like oracles themselves.
Right. That's the problem.
Yeah.
That's a problem with Wittgenstein. He even as a dead philosopher, he attracts acolytes, and that's unfortunate. And the thing about Wittgenstein is you get these piercing insights, and then you just get I think a lot of confusion or just muddled thinking, even in the philosophical investigations. I think though the impetus is that Wittgenstein was going on about is something that has been not necessarily should be identified with him, but the broad idea of usage as being the key to meaning. It was already out there in the linguistics community, certainly, in people like Edward Sapir and Leonard Bloomfield. So, it's not like Wittgenstein was suddenly baptized by the philosophical gods to tell us that we have to look at usage in order to understand meaning. I think many other significant people preceded him in doing that.
Well, I suppose that in that line, and it's been years since I read very much, there's probably many affinities between these ideas that I've been playing with, using scientific examples, and what some of the French structuralists were after. Right. So, and this is clearly somewhat in Wittgenstein, that usage is controlled by more elaborate checks and balances, let's say, and relationships between one pocket of usage and another. You get that in Austin too. Mm-hmm. But I think that's what the structuralists, but unfortunately they were so eager to have political morals. Mm. And this is actually the situation in philosophy of language. Everybody is so eager to do something about sexism and so forth that they're neglecting sort of the philosophy of language fundamentals that probably need to be examined. But anyway, that's the structuralists said things that didn't have enough examples in kind of less controversial context.
I'm not very familiar with who the French structuralists were.
Well, Lévi-Strauss, all those guys. Yeah, I'm not either. I've read them, but I forgot them. Because they're, again, I work by examples, mm-hmm. And try to have some theory of why language is doing what it's doing, mm-hmm. And
yeah, I think
so things like, I often will get associated, mainly because of living in Pittsburgh, with my colleague Bob Brandom. Mm-hmm. Well, he has an agenda from the word go, and I just don't work that way. I want to say, I think about puzzling examples, and that's why going back to Hertz, and in that book, he was worried about why force acts so weirdly. I mean, he was embarrassed that he couldn't teach it to freshmen because he didn't know what the fundamental principles should be and other things. And I just found it very profitable to go back to those motivating examples and see what things look like today. And it tends to be that a modern engineer using classical mechanics will use a much more elaborate set of checks and balances on their models. That's called multi-scale modeling. So I found it very profitable to study how that works. And so I get some sort of notion of structuralism, but I'm not going to have I'm a structuralist. I want to explain this particular way in which you can make improvements in language.
Well, let me just say, reading the draft that you sent around, Reasoning to Some Purpose, reminded me. So you said you used Weissman as a coat rack, and rightly so. And so Weissman has this idea of strata, or where a particular logic applies and it doesn't apply outside that strata, or something like this. And then there's the idea that language has this open texture. And what he was saying there reminded me of structural linguistics in a certain sense, in the sense of Zelig Harris, who I was privileged to know.
Yeah.
And the idea of that you really could study meaning only by attending to particular sublanguages. So sort of restricted areas of discourse bounded by context or problem or phenomena or whatever it would be. And that there you would find the clues to how meaning arises through usage in that context. And that's a very structuralist idea. So I see, this reasoning to some purpose paper following Weissman is very much in the mold of structural linguistics in the Hertzian sense.
You're undoubtedly right. I'm sort of vaguely aware of those precedents and things. Yeah. The particular thing that this would be the difference between Tim Maudlin and me is that Tim, in fact, whenever I finish this paper, I've had a heck of a time keeping it short enough. Well, actually, what did happen with the logical empiricists, and this carries through with Quine, is kind of a very reduced conception of actually scientific explanation and so forth. And what bothers me is that they paid no attention to what goes on and has gone on in mathematics at the same time. Right. And so in mathematics, they've learned that differential equation models come in all sorts of different classes that serve different purposes. And to get to a conclusion or reason to some purpose, you have to pay attention to the sort of explanatory matrix that you're dealing with and so forth. And so Tim has written about counterfactuals, but he's so, well, I'm trying to figure out how to say this quickly without spending too much time. He's attending to just one of these classes of differential equations that generate initial condition problems. So he has a theory of counterfactuals that make every counterfactual be like what a mathematician would call an initial value problem. And but mathematicians have long recognized that other profitable forms of explanation are not initial value problems. This is what I'm ultimately trying to get at in that paper. And they support quite different kinds of counterfactuals than Tim is looking at. And Tim is just in common with almost everybody that writes on that subject. It goes back to Goodman. But if you paid attention to the mathematics, you'll see these differences, right? And they're important and so forth because, of course, Tim also is locked in to this David Lewis view of that possible worlds are the key to straightening this stuff out. And that really goes back to Nelson Goodman, except he would have never accepted possible world as an acceptable form of speech. But it's still in that tradition. But the possibilities and so forth that come up in some of the things I'm eventually trying to get to in that paper are not possible worlds at all.
No.
And they show other attention to other forms of mathematical guiding clue or something. And I do think, I'm sure that it's very hard to find, that people like Weil are thinking of things like this often in what they say. And so there's just a whole dimension that, so if I was asked, I was thinking about it for this, what is the single most the single greatest problem that confronts analytic philosophy today, it is this trying to deal with these problems about the nature of law, say, or their role in explanation, still too much from a first order logic point of view, or first order logic supplemented with a modal operator or two, or even worse, notions of grounding. And they're not, I'm on all those, they're just trying to go learn from the applied mathematicians who long ago sorted out different kinds of problems into very finely into different categories that are now a lot of that's very hard, but I'm trying to bring some of that back into philosophy. But it would allow a liberalization and a better understanding of notions like causation and law of nature and so forth. And we got frozen in place with first order logic. And first order logic has done wonderful things, right? And axiomatics have done wonderful things, but they can't do it all. And so that's the heritage that we have that runs through Quine, right? And even through my former advisor, Hilary Putnam, and his views about natural kinds and all that sort of stuff. And that's where I started thinking that can't be right. So.
Are you in general opposed to using possible worlds as a tool, or is it just in some particular case where you think it's quite wrong?
Well, I'm talking about these particular scientific examples.
Okay.
Well, no, I mean, modal logic is useful enough in possible world, right? But well, I will say, I don't think your average philosopher has scrutinized the things that come up as natural counterfactuals and said, is that really a coherent, what do I mean by a world? Right. Well, I'll give you an example from Tim Maudlin. In that same discussion, he says, let's take a world of classical physics in which you have a round square and a blue cube. Now, I think I've studied the possible axiomatizations of classical mechanics as well as anybody in philosophy. I do not know of any formalism of classical mechanics that includes cubes or colors, So he's lost any discipline in what the notion of a classic, what a possible world could be. Now, there are things that about what a classical language is that would distinguish quantum mechanics from classical physics. There's a lot of differences, but that possible worlds is very vague. And I don't think Tim could tell you what theory of classical mechanics that he could possibly be thinking about. A lot of times I complain about this. Goes back to the continuum mechanics stuff. A lot of people think it is point mass mechanics, but that doesn't remotely sustain classical practice, right? Which Hertz was fully aware of. I mean, he didn't take that possibility seriously at all. And so, and it's just by being sloppy about notions like measure and just some mathematical notions that could possibly, or very sloppy about the notion of limit, that to think that. For some reason, Pat Suppies, who didn't know any physics, decided he was going to axiomatize classical physics, and what he did is a joke. But this guy Truesdell that Tom mentioned was one of the founders of a better approach to classical mechanics. and continuum mechanics. And he has a scathing review that many people thought was rude, but it is rude. Well, sometimes rudeness is okay. Anyway, when it's not directed at oneself. But he was just absolutely right that this was just otherworldly in view of the actual problems in practice of making sense of classical mechanics. Right. But that is still what metaphysicians of today rely on. Yeah. They think they know what classical mechanics is, and they talk about the models of classical mechanics, but they couldn't redeem in a million years, I don't think, what they even mean by that, and anything like approaching precision. But then they'll say, well, of course, I don't really mean classical mechanics because the real world is quantum mechanics and relativistic. And what is the axiom system for that? Things are, of course, notoriously fluid. That it's one of the great problems of contemporary physics. You don't know how to piece the things together, little alone in an axiomatic setting. And then there are a lot of deep problems that, talking about Duhem, that influenced me. Still, the role of thermodynamics in the organization of physics, I don't think we have a solid handle on. Again, your average philosopher of science will be very dogmatic about, of course, statistical mechanics can handle all that. And I'm not sure. So I don't try to make pronouncements like that. So
another preoccupation of contemporary metaphysicians that you mentioned was grounding. And I had Jonathan Schaffer on the podcast recently, so we've gotten the positive case for grounding for about 2 hours, but I haven't had anybody yet who was critical of grounding. And so maybe, I don't know if you want to weigh in on this as well, Tom, but what grounding is and what it's supposed to be and why it's a problematic fascination for contemporary metaphysicians.
Well, here's an example where I'll let him be rude.
Well, I don't follow this literature on grounding or analytical metaphysics in general, but it seems to me that the motivating idea is that we have to have some sort of notion of why our properties are attached to things in some truth-making way. And I guess that's where the grounding bit comes in. And, well, frankly, I don't see physicists that I know anyway talking about grounding. I don't see the need for it in philosophy if we can get by without it. And I think what it leads to are these cottage industries, really, in analytical metaphysics, where basically we have Gump theorists and grounding theorists and truth maker theorists and this kind of thing. And it's a lot of clever, logical rigmarole. I don't see what it has to do with truth or reality in any sense that is meaningful to me. So the same goes for talk of possible worlds. I think I don't see getting wisdom from papers that talk about the cardinality of logical space for different possible worlds, and Lewis's limit assumption about the cardinality of such a space. I don't see that that's a problem that I need to spend any time thinking about.
Mm-hmm. Yeah, the example. Go ahead.
Well, I was just going to say, much of the possible world stuff is derived from the assumption that if you got a scientific theory, you've got something axiomatized and it has models. right? And then there's this natural identification of those models with something called possible worlds. And occasionally that talk can be useful, but there's not been enough rigorous thinking about what's a model and when do you actually have a legitimate model in the sense of logic, and when you have something that is in good enough shape to be called a theory. And all these are major problems, and they have, and unfortunately, so many things have got off and up and rolling as problems that have not been thought through very well. Tom, just in passing, mentions this problem of gunk, which...
Could you say what that problem is?
Well, I'll try to describe it. It came up in David Lewis. Okay. Well, it is a project that there's some sort of problem with the notion of a point in a continuum. Okay. So if you got a fluid, and you have a point in the fluid or any kind of field, then that's a problematic entity. And all this goes back to Bertrand Russell and our knowledge of the external world. And he was talking to Whitehead, who was fussing with foundations of physics. I don't know quite what Whitehead himself thought, but the actual problem comes out of continuum mechanics. Hertz actually had difficulty with it, which is the foundation. What's the notion of a point in a fluid? And this is very much historically connected with all the problems of measure theory that got developed in that period. And it's the basic thing that you have a continuous fluid, okay, or a matter and so forth. The thing is that about the points in a fluid is that most of them will have a mass density. So there's which has to be related to larger masses. As you shrink down around a point, it should deposit a density locally, right? But because of all sorts of things like shock waves, picture is too simple. Because when you shrink down on a point lying on a shock wave, there isn't a density there. So there are all these very delicate questions that took Truesdale in his school to straighten out, and even there is very problematic, are these delicate issues of how the macroscopic relates to points. This isn't monological. This is making the mathematics work in a coherent way, and understanding what kind of limits are involved here, and how integrals, when they're well behaved, are well defined, and when they're not. So somehow that Whitehead was fussing with that, and Russell said, well, this is a great example of Occam's razor trying to get rid of these obnoxious entities. It's a misunderstanding of history comparable to that misunderstanding of what Hertz was trying to do. That they turn these things that there's this Occam's razor. Why should anybody want to get rid of anything that exists? But or say it's at least well defined. And so that so Lewis took that up, and this is a real problem in ontological reduction or so forth. And that's just a misunderstanding of the problem. And it was kind of funny. A student of mine who's at teaches at UCL, Sheldon Smith, called me up, who did very good work, and he says, Mark, when you weren't paying attention, all these guys in metaphysics have wandered into continuum mechanics. And I was asked to give a little plenary talk at some graduate student conference, right? So I gave a talk just outlining what I just said, called Beware of the Blob, which is remember the difficulties of making sense of what happens inside a flexible blob of jelly or water. And then somebody at Rutgers heard that I had done this scandalous thing of denouncing the importance of gunk, and then asked me to contribute to a volume. And then he says, well, you're not really being fair to those guys. I said, well, I'm sorry. Yeah, well, let me see it. But he wouldn't let me see the paper. Then when the volume came out, they were doing exactly what I thought they were doing, this ontological reduction stuff. But that's a nice example of just philosophy creating these goals for itself that grew out of some real life, non-trivial question that Duhem was asking or Hertz was asking, and it sort of metastasized into this independent satellite that drives a lot of analytic philosophy, right? Where I know Tom and I both think you got to go back, and these were not silly men, right?
Frege and Russell, like.
Well, no, I'm actually thinking of Mach and Duhem.
Okay.
Yeah. And
so
Hertz.
I mean, huh?
And
yeah,
Hertz.
all of these people, right? And somebody like Russell does not come off well compared to them.
No.
Right? He's a great philosopher, but nonetheless, I mean, that's actually, so, I mean, one of the things, and this goes back to Tom's day too, when Voss van Frossen said, had this weird, peculiar theory of constructive empiricism, but he presented it. He didn't really motivate it. It's, I am following in the footsteps of Mach and Duhem, right? And they would say things that you could quote if you, but actually they had real scientific concerns in mind that I think are real problems and are in somewhat, I would never say the radical things they said, but they are arguing for a certain greater tolerance. And in both cases, they're arguing for a way that continuum mechanics should be organized, that rationally one should have a lot of sympathy for. But but I got wondering, why do these guys say these silly things, right? But they weren't silly, but we've lost all track of that. And so von Frossen is just quoting authority it's just an argument from authority that's at the root, insofar as I could tell, at the root of almost everything von Frossen said. And a lot of analytic philosophy is driven by things like that. And it does require a larger measure of rethinking the history of these things, right? And that's where Tom and I would certainly agree. And though he's researched people that I don't understand very well, like Weil, but all of this stuff should be rethought. So we've settled into stereotypes of problems that we should. Oh, I'll say one other thing just on grounding that's in the same vein, because that actually gets started with my own thesis advisor, Hilary Putnam, was trying to answer how could two scientists from different backgrounds communicate with one another. And so he taking sort of what I would call junior high physics, you get these slogans like heat equals mean kinetic energy. right? And that comes out of a tradition in the 50s that those were property identities,
right,
whatever they exactly meant by that, right? But they're really just very rough slogans, right, that are hard to make clear at all, you know. But the notion that science is trying to find natural kinds. So science wants to know what water is, right? So it needs to find the essence of water. And then that, okay. And that claims about water are grounded in it there being H2O molecules, right? And they leave it at that. I was actually talking with a student here that wrote something about grounding. The issues about what, if I had to ask, what about water is grounded in anything? I would tend to say, well, gee, it's a fact that it can form hydrogen bonds in great clusters that fluctuate very rapidly in time. Now, those are features that make water be the kind of stuff, first of all, that will sustain life, right? And all of its peculiar properties that make it such an identifiable thing are connected with these capacities, right? And looking at just the crude classification, H2O doesn't tell you anything about that, right? So, because most of the time when there's forming these hydrogen bonds, right, they're ions. You know, it's just a much more complicated picture. And so there's a natural question of what grounds all these behaviors. I suppose that's an okay question, but I wouldn't turn it into a huge metaphysical category. But these appeals to grounding, insofar as I haven't paid that much attention, though the students had a whole bunch of examples, they're all very loose, right? And they don't point to anything particularly definite. And then, as I said, I just heard a paper that what they do point to is getting these metaphysicians to reject very important possible alternative definitions, like a circle is both a right conic section and the locus of points equidistant from a center, and a lot of other things that you know is a solution of a algebraic equation. All those are fine definitions of circle, and each one of them points you to deeper properties of what circles, right? But the grounding people, and I asked this question, the guy didn't answer it. He gave this ridiculous answer, is, do you prefer one of these over the others on the basis that one better grounds circle?
Mm-hmm.
And
begging the question.
Well, he said, well, those are necessary identities, so I don't have to choose between them. Then, of course, then you can give physical examples. And he was sort of stymied. I mean, we can't do this. I mean, these notions of alternative definitions are different explications of what's important about a circle or about H2O. Let's look at actual things you want to say, right? And I have not seen any, but maybe they exist, but by transcendental, I think by some form of induction, I'm going to assume that they don't. You have to look at those things with real life examples and ask, what do I mean? What am I looking for under that notion of grounding? Okay, so I given these historical problems, it just seems retrograde to me to introduce this notion and not pay any attention to what you're trying to displace, and the harm to productive axiomatization or rigorization that these emphases, these examples emphasize, are very harmful to productive science and productive mathematics. And I think they've gotten so detached from thinking about examples, they don't even occur to them that the degree to which they're not responding to real scientific needs. I don't know. What do you think, Tom?
Well, I think that's right. I think that the use of toy examples is all over in analytic philosophy. And I certainly think that there are situations in which one can use toy examples as heuristics, but they can't be the basis for grand metaphysical schemes. And I think in many cases they are. That's how it's done. I'm very much in favor of the suggestion that real life examples, which are ordinarily much more complex and require some sort of finesse in presenting, are much more instructive for whatever case they're being used for, to illustrate. It's so easy to create little thought balloons around toy examples. And so much of analytic philosophy, as Mark and I both know, is just fueled by these little examples. Blue squares and round, I don't know, circles or something. It baffles me that philosophers who are supposed to have some foot, I believe, in some other discipline besides philosophy, can just carry on in this autonomous way without looking about and seeing how the concepts in which we trade have real world application out there in the non-philosophical community. It baffles me that we think we can be productive philosophers by doing that sort of activity.
Yeah, that's something that I am always mentioning on the show, is that the philosophy I like most is the philosophy that's in dialogue with another discipline, whether it's mathematics or physics or linguistics or something like that. Mark, did you have anything else to say on this account? Or because then I had another question that I think will go back to some stuff we've already discussed.
Well, this is in the same order that frustrates me. So it's actually the fact that now, just in philosophy of mathematics, so we were talking about applied mathematics through most of, or usually for me, productive classical physics. But the degree to which philosophers are content to think that all you need to know about mathematics when you do philosophy of mathematics is a little bit about set theory. Right. So that gives you no understanding of why mathematics grows in the way that it does. And that is the reasonable criticism that the category theorists make, and my former colleague Ken Manders used to make. But if you want to understand conceptual change, you want to know what makes mathematics, well, this is certainly Hermann Weyl territory. You want to know what makes mathematics advance, and why, when and why it should add extension elements and so forth. And so thinking that you only have to pay attention to the justification of the whatever extension of ZFC is currently at issue, those are interesting problems, but you haven't settled all the problems. You haven't really had much of a sense of what makes mathematics grow the way it does. I wrote a little book about this recently, just a little primer, but that's really reduced philosophy of mathematics to a shell of what it should be. And now there are real issues about set theory, but those are issues that go back to things like measure theory and the fact that you need funny notions of limit that are non-trivial to capture very basic notions in the calculus of variation. What's the optimal path between A and B? Right. Well, that got Hilbert interested. That's where the notion of a weak limit comes. Takes subtle thought about set theory to understand. And then some of the stuff that I and my colleague Batterman worry about, where you're just talking about how large hunks of matter relate to smaller structures like a crystal lattice. Again, they're very fancy notions of limit basically to capture the notion, if you got a complicated molecular system, what does it look like a couple of levels up in terms of behaviors, And so there's a lot of functional analysis of set theory hidden there. And if you want to understand the place of set theory, you got to appreciate the good it does in those contexts. And that's just completely off. People are not paying attention to that. I'll tell you a funny story, and then so some years ago, it got to be the buzzword, yeah, we should do some philosophy of applied mathematics. So I got invited to this conference with a bunch of philosophers, and I had some little thing about differential equations. And all the other people there, what's that? I thought applied mathematics was, how do we get the number 2 to apply to the world? They talked about Russell. So I certainly felt like a duck out of water there, but that's a good example of getting shoehorned into a theme of great importance overall, but it's not the whole ball game.
Mm-hmm. So the question, though, that comes naturally to me from all of this, because I'm not a philosopher of physics, is that I know the names Mach, Duhem, and Hertz from physics, but I don't know much about their relationship to analytic philosophy. And when you say that Russell was a great philosopher, but in many ways he pales compared to these men, it makes me wonder just what it is that they contributed to analytic philosophy and what it is that you think we have forgotten that they were doing today that leads to some of the problems you've alluded to with contemporary metaphysics.
Well, of course, as Tom said, Duhem does contribute to analytic philosophy, but only in this Quine-Duhem kind of way, which it's there, but it's kind of a less than important. Well, I have to be kind of brief about this. Both of them thought that the drive towards kinetic theory, like you get in Boltzmann, was driven by a metaphysical urge that to have simple causal models of what happens in a gas. And they did, that's why somebody like Nancy Cartwright is partially right. They did think that you had to do a more top-down version of physics, where notions like entropy increase were part of the formalism, right? And so they were not so reductive. And they more emphasize, and this is comes into my own thinking, but I won't try to explain how, that that when you have a mechanical system, the basic idea of thermodynamics is coherent forms of energy or directed energy decay and lose their effectiveness, right? And that's where notions of heat and entropy come into physics. And they wanted to develop a formalism called thermomechanics, right? That would put heat and entropy on an equal level with the other mechanical concepts, right? And in fact, the 20th century development of continuum mechanics has done exactly that. It really has followed in the steps and kept a lot of the things that Duhem recommended and improved on them, right? And that has led to a much more practical formalism applicable to real life events, right? That is what particularly Duhem sought. And Mach all had similar beliefs, but he didn't accomplish so much in actually making suggestions. But they thought metaphysics was prejudicing the direction of science in ways that weren't profitable. Now, they were too harsh on that prediction, but they were right to emphasize the profit if people followed. So this thermomechanics that they sought is a very profitable enterprise. Okay. And so out of that, so because he thought that the notion of causation, and as you would have gotten in certain 19th century philosophers, the principle of causation, that everything had to have was behind this prejudice in favor of reductive kinetic theory. Right. And so he was a guy that said, well, really in physics, the notion of cause isn't important. All you really need are formulas. Right. And so Russell wrote on the notion of cause in, I think it's in Mysticism and Logic, saying pretty much that thing, it's just formulas. And I believe he took it from Mach. It could have been other people, but he didn't credit Mach. And he gave pretty crappy reasons. They weren't these reasons that trying to avoid a prejudice towards kinetic theory, that in some sense, both Duhem and Mach were right about it. It was excessively dogmatic and it was growing out of some form of metaphysics, which is why they opposed metaphysics, particularly Mach, and was an influence on Carnap and all the people that came later. But they had actual reasons. You can understand better what they were opposed to, and there was a lot of wisdom in that, not the whole story, right? But even today, I had a big argument with David Wallace the other day we'll quote that Russell, he's absolutely right. There's no cause in physics. Well, that's careless. There are different ways in which the notion of causation is enshrined in many of the basic equations of physics, right? Maybe not in the fundamental sort of way. And that there's a difference between, I've written about this, different classes of physics. But for the ones that I called these evolutionary equations that Maudlin was emphasizing, which are natural, then built into the equation are the so-called characteristic curves, which are the pathways of causal influence. It's right there in the equation. Those pathways of causal influence are what carve out the light cones in optics, but they carve out sound cones if you're dealing with sound, And so there are mathematical structures deeply aligned with the differential equations, right? And if in a linear case, you use those basic fundamental solutions to build up more complicated solutions, that embody those basic or fundamental causal processes. So but very few philosophers will still quote Russell or just take it for granted, and they don't pay any attention to this, which has been known since the time of Russell's, because it's all the great mathematician Jacques Hadamard, who's one of my heroes, wrote about it in about the same period as Russell was writing. And it's these basic constructions are in every book on partial differential equations. But in some other equations, they aren't there. But causation enters those kinds of contexts with a different spin. So that's one of the things I'm trying to work on, and there's some of it in physics or the new book, right? Just and why language acts like this, why cause doesn't have a common meaning, but why it has a lot of utility in different contexts, and so on. And some of the big controversies about causation I hear about from my colleague Jim Woodward are not noticing there's kind of these two sides, there's these multiple sides or ways of defending how causation comes into physics, right? But anyway, a lot of it goes back to Mach, and there everything was reasonable, but then that's why Russell borrows from Mach, but doesn't understand that context in which Mach, to me, was saying some important or keeping possibilities open, right?
I just want to add to what Mark said, that Robinson, you were questioning the linkage from Mach and Duhem and Hertz to analytical philosophy. I think one of the great tragedies that occurred was that Mach and Duhem and Hertz were dealing with mathematics, real mathematics, differential equations, and analytic philosophy through Russell and through Frege. The substitution was made for logic and set theory. And I think...
What do you mean, really quickly, though, distinguishing real mathematics from set theory? I mean, it's like the typical sort of... I mean, most mathematicians kind of, I think, scoff at mathematical logic.
Well, I think real mathematics, in the sense that we're talking about it here, it's the mathematics that arises from trying to solve problems in physics.
Okay, sure.
And I think that's the sense in which it was of use to Hertz and Duhem and et cetera. And then from an independent direction, really, through Frege and Russell, the logical empiricists, the precursors of analytic philosophy, largely substituted logic. Schlick was an exception, the one exception, I think, in the logical empiricists. He actually was a student of Max Planck and wrote quite a significant dissertation in mathematical physics on the scattering of light in a inhomogeneous medium, in the early part of the 20th century.
And am I correct in recalling this from earlier, that the two of you, or at least Mark, you think that while first order logic is extremely important, it's been overemphasized in analytic philosophy?
Yes. So I'm trying to use Weissman to bring in the fact that some of the you can have a service first order logic where soundness proof tells you a lot, but underneath it there are other sorts of considerations that get taken care of in practice by moving to different models. And to justify some of those other moves, you need to look at quite different sort of mathematics than this being hidden by that surface level. It's not the surface level and the things that come with certain notions of rigor that come to which the development of quantification theory has been a great boon, right? Nonetheless, there are these sort of subterranean things that also need to be paid attention to understand when you have good reasoning, right? And so I've been interested in what are called correctness proofs, like for numerical methods, right? The way that you'd actually get a computer to give you an answer, right? And the lines of thought that you have to go, that you involve, are taking in a much more complicated or a different direction than what you see in a soundness proof. So I'm just trying to get people to look a little bit below the surface, and then going back to what we're talking about, the possible world stuff, and then trying to treat everything that looks like a counterfactual as belonging to the same category and mushing them together by saying they're possible worlds. They're not attending to some significant differences in these subterranean elements that mathematicians understand pretty well.
Now, Tom mentioned open texture earlier, and that was something in your paper, Reasoning to Some Purpose. And is that an example maybe of where first order logic fails us because it's not equipped to deal with vague predicates or more broadly open textured predicates? Is that why that's significant in this context?
Yeah, I'm of two minds about that. I mean, my first real paper I ever wrote is, in some sense, why I objected to Putnam and natural kinds was the realization that how many of these terms behave are going to be contextual clues are going to direct you in one way or another. Okay. And so I've often taken as my model, and this is a lot of this in Wandering Significance, is that you have a patch of reasoning, and then there are various ingredients that will induce you to move into an adjacent patch in a certain sort of way that will seem right. And my model for that is analytic continuation, right? And then I very briefly sketch it in those notes I sent you that, but Weissman actually says something kind of like this, is that exploratory following these local forms of natural continuation. That's more what I think of open. It's not quite open texture. It's a kind of guided continuation, right? And if you go too far, then you get into clashes, and that's what Hertz was worried about. By doing things that seem locally right, if you put them all together, they clash with one another. And then the thing that you get actually from Riemann, but also from the multiscalar things that are happening in physics, you can keep those patches from clashing with one another, but still benefit from them. Okay, so that's kind of my main structural sort of theme, right? And So, and that's what I'm trying to develop, but trying to do it with simple enough examples that by force has all sorts of natural continuations, as Hertz rightly noted. But if you keep them all, if you can use all of them, but if you control them in a certain sort of way, you can make surface level force have a pretty stable extension. Okay, so by a lot of you can take things that look open texture when you just look at them one by one. You piece them together, you can get something that is much better. I think I compared it to a piece of plywood. You get a stronger, a more robust linguistic structure. And this is where Weissman's talk about strata would come in. By having various control layers, then things that look like open texture are sort of an engine that will actually eventually lead to a quite effective form of linguistic description. Does that make some sense? So, so in that sense, it's not like vagueness. And even Weissman says this really isn't vagueness, but it is. It's more pragmatic, I suppose. You locally discover some way of prolonging a usage that's manifestly rewarded as useful. But you don't know how to carry it out to give you a full extension for whatever the property is, okay, on its own. But it still is caught onto something useful, and you want to always preserve that utility, which you can do by just controlling when you use it and when you don't, when you use one continuation as opposed to another. And there are lots of examples in the history of science like this one. Of a case I wrote about at great length is Heaviside operational calculus, where he discovered these patterns that it took a long time to see how they all fit together. That took until 1950s, but tremendously advanced people's ability to pull information out of differential equations. Right. And Riemann actually did that for Euler's explorations in computing with complex functions. So this is so well, I'm sort of, there's some sense that's in union there is strength. By taking these various forms of natural prolongation and using them wisely in conjunction with one another, you can actually build up a much better descriptive system. Okay, and it has structure you have to pay attention to about how you keep it from being contradictory in the way that Hertz worried about, But so this is a kind of these are the kind of themes I'm sort of exploring. Is that okay? Mm-hmm. So, but it's not thinking of vagueness is actually trying to, that legion, what's the logic of vagueness? I don't believe there's a logic of vagueness. Right. There are ways in which we can use language like boldness. I always hate this example.
Me too.
Yeah. But it's usually more subterranean controls that we sort of gradually build up that take care of the borderline cases when they're going to be important. Right. And so I think we just need more of a structural arrangement to understand even why vague predicates are useful. But I think it's actually better to use these natural prolongations where you see immediately why the prolongation is useful, because that's what inspires it, Euler looks at calculations with complex numbers, and he sees, well, if I just pay attention to power theories, I can get into the patch next door and learn something useful there. Right? Well, that's useful. It's just that if you try to immediately, well, what's common to all these things, then you get into actually potential paradoxes. But what Riemann did is give you a global view of how these things should fit together, and when you should stop, tell you how to stop the strands of reasoning that lead to paradox. And so, and those are sort of structural correctives and so forth. So it is a kind of different view of how to control, how to make language maximally useful, but avoid destructive connections. And first order logic is just all one level. Right. So we got to get some other levels in there to control some of this stuff.
Mm-hmm.
Okay. But then, and again, I do think that assimilating open textures, a lot of people to vagueness is just a mistake. I remember once back when I wrote that monster, Wandering Significance, he and Dora, who was my colleague, that's just vagueness. But it wasn't vagueness. It's a different kind of phenomenon that requires different resources to deal with. And at that time, I didn't really understand about multiscalar methods that they use in engineering now. But that's a wonderful model of how you can make a locally problematic language be enormously effective. So you can't, well, there at Stanford, you go over to the engineering, you walk through the halls, if they have posters, you'll see a multiscalar approach to X, Y, and Z. And that's because by stacking up submodels in the way that I try to outline, engineers' capacity to simulate materials have quadrupled or just vastly improved, right? So they don't have to crash quite so many cars into brick walls. They probably should do more than they do, but the ability to simulate things like a car crash are just enormously improved by stacking up calculational techniques in a wise sort of way.
Yeah, I would just say that Mark has this wonderful metaphor for the contrastive method of theory T thinking, which is that, in physics, there's such a thing as a marching method, where you can just carry on doing the same thing across all these multi-scales of application. And that's how the game is played. And of course, that's not how the game is played. You can't get answers to questions you want to ask using that way. So I love that term, marching methods.
Well, that's a standard mathematics term but actually going back to, I guess we're kind of beating up on Tim Maudlin here, but he basically is trying to understand all counterfactuals as if they were secretly involved versions of the marching method. And that's not right. I mean, their marching methods are often very inaccurate. And if you know that a system is going to reach equilibrium, there are alternative methods of reasoning to some purpose that take you in a different pathway. That's eventually where I'm trying to head. Okay. But those are called relaxation methods, if you want a title, so anyway. So there's a bunch of stuff in this general region that somehow is not penetrated into analytic philosophy at all, that I can tell.
I wanted to come full circle and sum up and see if we've missed any things. But Mark, you indicated to me in an email that you thought it would be interesting to discuss the current state of analytic philosophy. And then Tom, in one of your writings, you wrote that Mark's books comprise a many-count indictment of reigning philosophical complacency. And so we've talked about a few things. I mean, one, that modern or contemporary philosophers aren't in sufficient dialogue with the sciences or the mathematics that they purport to philosophize about. And then there's an over-reliance on first-order logic and possible worlds maybe as part of that. But are there any other major problems you see with contemporary analytic philosophy that we haven't addressed yet? I mean, one thing, I don't know if you have this in mind, but I mean, the paper churning is sort of not a very effective way of getting good philosophy out there. But that's not so much actual philosophical practice as a stipulation placed upon us by administration.
Well, I think that I would add to this, philosophical training should teach students to get their snouts out of philosophy books and to look at things like math texts and physics texts and economics texts and, I don't care, sociology, whatever, it doesn't matter, linguistics, and actually see how working methods in the sciences are achieved, and the struggle to develop these working methods. I mean, science is not this straightforward march of progress. I think that would be so helpful to see the changes, the significant people who implement those changes in these disciplines and what problems they were addressing. So I think, you could say, well, that's asking a lot, too much maybe for philosophical education, but I certainly think it's part of anyone's agenda who purports to be a philosopher.
And now clearly, I mean, a philosopher of math should be learning some math, a philosopher of physics should be learning some physics, but then there are some disciplines that might, at least at first glance, not naturally intersect with a science or another domain, like maybe epistemology, maybe even metaphysics, according to some people who don't have this idea about its relationship to physics. So,
I disagree about epistemology. I mean, the French have this term, epistemologie, right? And it is really the history of philosophy of science. It's the history of science coupled with philosophy. It only exists in France in this significance. But I find that, racking one's brains about the necessary and sufficient conditions for S knows that P is just not very productive.
Okay.
Now, I would probably slightly disagree just about. So I am sort of more, but fit myself into the school of common sense to some extent, that maybe is exemplified by somebody like Austin, right? And your fellow student Kelly was out here and so forth, and she was working on problems about explanation and so forth. I used to talk about with my brother, who was a first-class ordinary language philosopher of the old Cornell school. And I have tremendous respect for people that are just sensitive to the nuances of a problem or a way of speaking. I could never duplicate what my brother could do because of not having that ear for language. and common sense. But that's ultimately what, what keeps language coherent and useful and so forth. And also, anyway, so I just use mathematics myself as partially because of this great pressure that your generation feels to have theorems and things like that as accomplishments, when it really just requires more deep thinking about the motivations of these problems. And I use science just because it gives me good examples that I can hold on to that are relatively precise, where you can say structurally, they're doing this because of that. Right. So we do this with force because we can correct for this problem. But any form of philosophy should be able to deal with that, and you don't have to deal with mathematics at all. Right. It's just that I think Bob Brandom said that I'm an ordinary language philosopher, but my language is engineering. But so that but it's also because of these things that Tom and I were talking about, the heritage, the bad side of the heritage of logical empiricism that led to people like David Lewis. That still has too much of a stranglehold. And it also affects your generation. So I really pity you as opposed to us old guys, because you have grown up in a thing with all this premature demand for publications. And when people go to graduate school now, it is kind of like you're in biology, you sign into a lab and have to sign, to investigate how DNA, and you're stuck with it for the rest of your life, or you get signed onto a program when you first enter graduate school. But really, it'd be better to muse a little while and follow the pathway of just curiosity and common sense, and don't get committed to a program. And then the idea that rigor, I had a bunch of colleagues like this that just pride themselves on the rigor, and they proved trivial theorems that anybody in physics could prove in 5 minutes, and then they label it with something, the unreality of the world or something like that. That's not what philosophy should be. Philosophy needs to be looser and more willing to kind of step back and think, what's going on here? And, just like, what makes us have to think like this? Why is it productive to think like that? And so it is good to look at mathematics and so forth, but that's not the essence of philosophy. I would more place it, language is very strange, and what makes it work takes a lot of thinking, and it's surprising. So that would be rather than, and you're not going to figure it out by having a little axiomatization. You've got to just use common sense. Why are we doing this? Okay. So I'm not trying to get other philosophers to imitate me, and learn a lot of continuum mechanics. It's useful for understanding history of things, but I just want them to pursue what seems commonsensical.
Well, when I first got to Stanford, I nagged Tom about doing an episode with me on maybe Einstein or Bohr or something like that. So I'm glad, Mark, that you suggested that I reach out to Tom about doing an episode with both of you, because this has been really fun. So I am so thankful that you both joined me for this episode. Thanks.
Okay.
Thank you.
Hold on, Geeslings. Before you go, please like, subscribe, follow if you haven't already. Smash all those buttons. And also, if you haven't followed me on Twitter at Robinson Earhart, or if you're not joining me every morning as I eat my pint of ice cream on Twitch at Robinson Earhart on Robinson Eats, please do so.